guys, in the last few videos we worked through the process of building a reflow oven both in code and in the actual implementation. This is a video designed to kind of finalize on those ideas. I apologize for not having more in-depth sort of, as you go tutorials with the basics, soldering, assembly, whatnot. But as right now I'm kind of limited in my camera resources. I simply have an SLR that I have on a tripod. I wasn't really able to do that. I mean, I can't have the tripod sitting right here. So what I'm going to do is I'm going to come up and I'm going to grab it off the mount. I'm just going to walk around and show to the camera the basic components of the reflow oven, and I'll discuss the various challenges I had while building it and whatnot. So this is going to be a real quick video. It's going to summarize the past two things, and in the next few days I'm going to do another segment of 2 or 3 videos on reballing BGAs. Basically I have a few high pin count FPGAs that I need to reball, so I can sacrifice a few to science and YouTube enjoyment and reball them as a tutorial kind of thing. So that being said, let's get on with it. The camera is really not focusing properly, but up here you can basically see the reflow controller, as also the SSR, which is right in there. The relay is cabled into the heating contacts over here, as well as the fan contacts for the convection motor. Also, we have connected through a couple banana posts the thermocouple, which leads into the convection grate into the actual, cooking chamber, heating cavity, whatever you want to call it. What I chose to do when wiring the SSR was I chose to wire it through the fuse that's already in place. That way it gives us sort of a little bit extra protection in regards to the heating element. Nothing's going to blow out. We're not going to exceed the current rating on the SSR and whatnot. There are a few things that I had as challenges that still have to be kind of proven by, flipping the switch on this thing for the first time. The first is that in the original wiring, the convection motor for the fan that actually circulates the hot air was mounted somewhat like 180 degrees out of phase in the AC cycle with respect to the heating coils. What it was a single return line and 2 different AC feeds going into each line, and that you can kind of see down there with the original wiring bundle that I just kind of shoved out of the way. And what I did in this build was I just wired both the fan and the relay coils and the heating coils just in parallel. I mean, I don't think it should make too much of a difference, but at the same time it's one of those things where I'm not going to put, $3,000 worth of FPGAs in this oven and then have it explode. That's foolish. The other thing that I just want to do, I mean, as a kind of precautionary measure, is remove this Magnetron transformer along with all its rectification and filtering circuitry right here. This is because, this thing is going to be putting out a couple of 1,000 volts, and a typical Arduino isn't going to like a couple of 1,000 volts if when I put the case back on, if it pushes the contacts close enough to get an arc going, I'll just blow the relay circuitry right out. And there are a few other things. I mean, in the grand scale of things. Here, let me go put it back on the mount. My apologies for a clumsy camera handling and whatnot. In the grand scale of things, there are a couple modifications I want to do to the oven eventually. First is the addition of another microcontroller platform that will communicate with the actual reflow-oven controller via whatever serial protocol you want to use. And what that'll do is it'll allow you to set the reflow profile, so it'll know the temperature states for various different solders as far as 6040s, 6337, and then all your non-leaded solders, which are a pain in the ass. And the other thing is to truly revamp the circuitry, get all this crap out of here, and completely redo it so that it's 100% an integrated platform. These are longer term kind of goals. The final major disadvantage that I had when wiring all this together was that I couldn't find a stable 5-volt source from within the oven. So for the time being, what I'm going to have to do is plug a USB cable in and run power into it manually, which will obviously require that I have my laptop sitting right next to the thing while I want to do the reflow. I mean, at this point, it isn't too much of a problem, but it is definitely something I want to work to fix. And in fact, the next thing I am working on that I will do a bunch of videos on is a programmable buck boost controller. Or essentially what a buck boost converter is, are there various types of DC-DC converter, that is DC conversion without needing a transformer. And so what I have in mind is building a programmable one where you can change the output voltage and whatnot in real time. So, as I said, that's pretty much going to be the actual next project once I get my head in order and I have some more money that I can use to get cameras and, you know, other equipment. Then we're actually going to start getting into actual machining, such as CNC milling, welding, stuff of that nature. So that's what's in the, you know, long-term forecast for right now. Alright folks, thanks for watching, and remember, if you like what you see, subscribe. If you want to tell me I suck, do it in the comments. Yeah.